Hi students, today let us discuss about class A, class B, class AB and class C amplifiers. How they are classified and what are the main important advantages, disadvantages. So all the points we are going to discuss now. First of all, a transistor is used for amplification and it is connected in common emitter mode. You know that. To keep the input junction forward bias and output junction reverse bias, we have a biasing circuit. So this biasing circuit R1 and R2 are used here, and this circuit is used here to keep the output junction reverse bias and the input junction forward bias. So this is called biasing. And RE is the stabilization resistance, which keeps the temperature effects on this circuit very minimum. And this is a CE, bypass capacitor, and here you will have C in input capacitor which blocks DC. And this is the signal, input signal, which you want to amplify. So this is weak input signal, and this is the earth. And now at the collector you can draw a transformer, because all these are power transformers, power amplifiers. Therefore at the output, at the collector, you must draw a transformer. Then this is the output. To take output, you are connecting a speaker. Then the input signal, when you observe it, it will have a positive and a negative waves, both positive half cycle and negative half cycle. When it is given to the transistor at exactly 0.7 volts, the transistor is switched on. This is called as switching voltage of the transistor. If you don't have R1 R2, let us discuss for some time. So when the input signal is 0.7 volts for silicon transistor, this silicon transistor will be switched on, and after reaching the maximum voltage, let it be 5 volts, and then falling to 0.7 volts. Up to this point, the transistor will be in on state because it needs 0.7 volts to switch on. Therefore, at the output, you will have the signal like this. You don't have full half cycle and you don't have negative half cycle also. So, to keep this transistor in on state, for the complete input signal, you must give a constant DC, which is called as biasing. And this biasing will keep the operating point Q of the transistor in active region. Therefore, to make this, you have to apply 5 plus 0.7 volts. 5 plus 0.7 volts. That means if you apply 5.7 volts, then 5.7 plus minus 5 volts, this is equal to 0.7 volts, which makes the transistor to drive into on state. Therefore, if you want the complete input signal to appear at the output, then you must apply the biasing voltage, which is more than 0.7 volts to that of the input signal, input peak voltage. Okay, then the transistor will be in active region for the whole input signal. Therefore, you will get the output completely, both positive and a negative half cycle. So positive half cycle will be turned like this into negative half cycle, because transistor will introduce 180 degrees of phase shift due to its working. So you will get negative half cycle, and then positive half cycle. So there will not be any loss of the signal. So this type is called as class A power amplifier. Class A power amplifier. That means the collector current IC flows for the complete set of input signals. Then it is called as class A power amplifier. Here you can observe that there is no loss of the signal. There is no loss. So loss is not there, and also distortion. Distortion means is the output signal resembles the input signal. Both are same or not. So if it is, if they are not same, then you can call it as a distortion. So here distortion is not there. Distortion is not there. The complete output is just like the input signal. And then when you give the input here for class A, you must have to give a biasing voltage of 5.7 volts. Okay, now let us start with a 0 plus 0.7. Here the signal you want up to 0 volts. That means you want only positive half cycle. Positive half cycle, half of the signal. That means 180 degrees of a collector current. Then the output, the biasing you have to apply is 0 plus 0.7. So 0 plus 0.7 means you have to apply 0.7 volts of biasing. Then it is called as class B. Here the collector current IC will flow for only half of the input signal. Half of the input signal. Class A, the collector current flows for the complete 360 degrees, whereas in class B, collector current flows only for 180 degrees of the input signal. And now when you apply the biasing signal in such a way that you will get the full half cycle, positive half cycle, and a part of negative half cycle, then the biasing you should have to apply is, for example, up to 2 volts. Let it be from up to minus 2 volts. Then 2 volts plus 0.7 is equal to 2.7 volts. This will make the transistor collector current to flow for the complete half cycle of the input signal and a part of the negative half cycle. Okay. So you will get both positive and negative, but here the complete positive half cycle and a part of the negative half cycle will appear at the output. So here you can tell what is the distortion and what is the loss of the signal. You can calculate. Okay. And then when you give the biasing voltage in such a way, then this is AB. Now the biasing voltage is, you are not giving any voltage, biasing voltage, let it be 0 volts. Then the transistor will conduct only for a part of the positive half cycle, part of the signal only, because here it has to reach 0.7 volts and again at 0.7 volts it will be switched off. Therefore, you will get only a part of the positive half cycle. So this is another type which is called as class C power amplifier. Here we can say that there are four types of power amplifiers. They are class A, B, AB and C. You came to know here. So now you can observe that the input signal has both positive half cycle and a negative half cycle. This is up to 360 degrees. Here the biasing is selected in such a way the output current IC will flow for the complete degrees of input signal. So you can observe that there is no signal loss in class A power amplifier. This is class A, output of the class A power amplifier. Here you can observe there is no signal loss. Therefore, you can tell very less distortion or no distortion is there. But when you talk about the efficiency, how much it is amplifying means it will have a 25% of efficiency. Only very minimum efficiency will be there, but the signal loss will not be there. That is the main advantage of class A power amplifier. And then here power loss and heat. You know that the transistor is in on state for the complete input signal. Therefore, it should be in on state for the whole time of the input. Obviously, it will be heated and there hence power loss will be more. Power loss will be more in a class A power amplifier. And then what are the applications means? It is used for very low frequency applications. Low frequency applications can be used as a class A power amplifier. And then when you take the class B, so here the class B, the biasing is taken in such a way, biasing is selected in such a way that the collector current IC flows for exactly 180 degrees of the input supply. Here we said no, that 0.7 volts plus 0. 0 means here both the points are 0. You want up to 0. Then 0.7 volts plus 0 is equal to, the biasing should be equal to 0.7 volts biasing voltage. Then the transistor will be switched on at 0. 0 plus 0.7. That means here, and it will work for the total 180 degrees of input signal. Then it will be switched off. So the collector current IC flows for 180 degrees of a input signal. You can observe the input signal and output signal are not same here. There's no half cycle. Only half cycle is present. So you can tell that it has a great distortion. More distortion is there. Distortion is high. And also it has another problem which is called as crossover distortion. What is crossover distortion means? Already we said that the transistor has to be switched on at 0 volt and it should be switched off at 0 volt. But it will not be done properly by the transistor. It takes some time, some microseconds of time. So this will lead a distortion which is called as crossover distortion. Crossover distortion. Here the distortion is high and also it is named as crossover distortion. It has crossover distortion. And then when you talk about the heat and power loss, it is less than that of the class A power amplifier. It is less than that of the class A power amplifier. Applications are audio range. It is used for audio frequency applications. And now this crossover distortion has to be reduced and it was done using class AB power amplifier. Class AB power amplifier is designed in such a way that the collector current IC will flow for more than 180 degrees, and less than that of the 360 degrees. So the conduction angle will be more than 180 degrees, and less than 360 degrees. So at this time the collector current will flow, the Q point is adjusted and it is done using a proper biasing. Biasing is set in such a way that the collector current IC flows for more than 180 degrees and less than 360 degrees of input signal. Okay, so here you can observe the efficiency. For class B, it is nearly equal to 75% of efficiency will be there, but for class AB will get nearly 60% of efficiency. 60% efficiency will be there. And it has a distortion to some extent, but the distortion is less than that of the class B power amplifier, because we are losing only a part of the negative half cycle, not the complete negative half cycle. Therefore, distortion is less than that of the class B, but more than that of the class A amplifiers. You can tell. And then power loss will also be there, but it is also in between class A and B, as its name shows. And then it is applicable in high fidelity audio system. High fidelity audio systems, it is used where high fidelity is required for excellent audio quality. And then class C power amplifier. Here the class C power amplifier, the same definition repeats, but the angle of conduction of a transistor IC is less than 180 degrees. It is less than 180 degrees. That means you won't have either the complete positive half cycle or a negative half cycle. You will have only a part of the half cycle. That means the IC flows for less than 180 degrees of the collector current. So this will make you a more and more power loss, but its efficiency is much more, and it is nearly equal to 80%. This is just like that. When you are studying, for example, for 1 hour, you have to learn 4 questions. Then your efficiency will be minimum. If you want to learn 3 questions, then that efficiency will be somewhat more compared to 4 questions. If you are learning only single question, then your efficiency will be maximum. In the same way, here the complete signal is there, so its efficiency is minimum, and this efficiency is 60% when you are taking more than 180 and less than 360 degrees. And so on, these two efficiencies. Then when you take the distortion, here also distortion is more because it is not, the output signal is not similar to input signal, because you are losing a part of the input signal. So distortion is more, but the distortion will be in between A and B, more than B and less than A. Next, power loss. All the amplifiers will have power loss obviously, but their power loss will be more here and goes on decreases. And then here also more distortion is present. And then it is used for RF signals, radio frequency signals. So this is the classification of power amplifiers, which are called ABC and AB. Here the main point you have to note down is the collector current IC flows for dash degrees of input signal. So here you can fill for 360 degrees of input signal, then it is class A. And IC flows for 180 degrees of input, then it is class B. If the collector current flows more than 180 degrees and less than that of the 360 degrees, then it is called as class B, AB power amplifier. So here the theta is less than 180 and greater than 180 degrees and less than 360 degrees. Here I wrote it correctly. And for class C, it is less than 180 degrees. Okay. So this is about the power amplifiers classification. Thank you.